Hey, Mr. Kaczynski here, and I'm working on IXL's Algebra 1, Section L. The last skill in this section is graphing solutions to absolute value inequalities. In my last video, I solved absolute value inequalities, so today we're going to solve them and graph them. As a reminder, from when you initially graphed inequalities, when you see this less than sign, we're going to show that with an open dot at the point where our interval starts with an arrow to the left. Greater than, we'll put an open dot at the start of our interval with an arrow to the right, as opposed to less than or equal to, where we use a closed dot to show that the point where our interval starts is also a solution to our inequality, and then an arrow to the left, and of course greater than or equal to, an open dot with an arrow to the right. Alright, so what I've chosen is an example for each one of the four, and we'll see kind of how that graphs out differently. I have seen other ways instead of open dots and closed dots where people use parentheses for open dots and brackets for closed dots, but this is the way I've always taught it, and this is the way IXL does it as well. So here's my first one. The absolute value of p plus 35 is less than or equal to 45. I'm going to write an equivalent compound inequality. P plus 35 is between negative 45 and positive 45 inclusively. That means including those two numbers. And I'll solve that by just subtracting 35 from everything. So 45 minus 35 is 10, and negative 45 minus 35 is negative 80. So there's our solution set from negative 80, including negative 80, so the closed dot, all the way to 10, including 10, so the closed dot. Everything in between there, including those two numbers. So that's our solution right there. That's how we would graph this. All right, the first thing I would do on this one is actually, I'd flip it around. I'd make it the absolute value of c minus 4 is greater than or equal to 5. I like working with absolute value inequalities where the absolute value quantity is on the left side. So now I'll write my compound inequality, and I'm going to say c minus 4 is less than or equal to negative 5, or c minus 4 is greater than or equal to positive 5. So there's the difference between less than and greater than. This is going to be two different intervals that make up our solution set. All right, so this one on the left, I'll add 4 to both sides. And I get c is less than or equal to negative 1. So or equal to is a closed dot, less than, arrow to the left. And then this one on the right, or this green inequality, I'll solve it by adding 4 to both sides. And that gives me c is greater than or equal to 9. So again, a closed dot at 9 and an arrow to the right. So that is how you graph this solution set right here. Next up, on this one I have to isolate the absolute value quantity first. So the first thing I have to do before I write my compound inequality is add 2 to both sides. Once I have the absolute value quantity isolated, I can write my compound inequality, which is that c minus 8 is between negative 20 and positive 20. And then I can solve it by, oh, I forgot an 80, didn't I? That's a big difference. All right, so we'll throw that 80 in there. All right, and then we'll solve it by adding 80 to both sides. So that's 100 over here and 60 over here. All right, so how do we graph that? It's going to be an open dot at 60 and an open dot at 100 because those are not included in our solution set, and then everything in between them. So that's the graph that shows all numbers between 60 and 100 exclusively, meaning not including 60 and 100. So isolate your absolute value quantity, write a compound inequality, solve it. All right, last one. First, we got to isolate the absolute value quantity. That's going to take us 2 steps this time. First step is to subtract 8 from both sides. Then I'm going to divide both sides by 5. All right, now I can write my compound inequality, which is 15 minus 5b is less than negative 10, or 15 minus 5b is greater than positive 10. And let's solve this. Notice something crazy kind of happens here. Not really, because we've done this several times. The first thing I'm going to do is subtract 15 from both sides, which gives me negative 5b is less than negative 25. And then I'm going to divide both sides by negative 5. And when you divide by a negative, your inequality flips. So it's actually b is greater than 5. So that would be an open dot at 5 with an arrow to the right. All right, the same thing's going to happen over here. Let's subtract 15 from both sides. Get negative 5b is greater than negative 5. And then divide both sides by negative 5. You get b is less than 1. All right, because we have to flip that sign, that inequality around when we divide it by the negative 5. So less than 1 is an open dot at 1 with an arrow to the left. And that is our graph for this solution set right here. B is greater than 5 or less than negative 1. All right, so that's solving inequalities, absolute value inequalities, and graphing them. Good luck. Let me know how it goes.